Alright guys, before we start this video, I want to make sure that you're doing it the right way. So here's what you should be doing to prepare yourself for this test. First thing you should do is take this practice test. This is after you finish all your work and you're ready to go. You feel like you're ready and you've studied. Take the test, and then when you're done, go to the end of this video and check your answers. Once you realize which ones you got wrong, then you can go, what I would do first, I would actually check to see if I can figure out what I did wrong. But if you can't, or you want some better explanation, then go back to the video where I went over that problem and watch those select solutions. Again, when you take the test, I will not be there doing the problems out for you, so don't do that here. It's not going to benefit you. You need to take this like a practice test and then check your answers and then review. Okay? So with that being said, I'm going to go ahead and get started with number one. So number one, it says, what else must you know to prove the triangle is congruent by angle, side, angle? So if I'm going to use angle, side, angle, I need to look at first what I have. Well, I have an angle and a side and then another side. So I have an angle, side, side relationship saying what do I need to be able to do angle, side, angle? What's missing? Well, here, if I'm going angle, I have to start here because, it's an angle. So here I start angle, side. You can't go this way because you're skipping this side. Okay, so that's important to understand. But I'm going to go angle, side, and then down here I have an angle. Same thing over here. It's the same scenario, right? Angle, side, angle. So the answer to this one is what you need is you need to show that angle Z is congruent to angle T. If you wanted, you could also say YZX and STR, or XZY and RTS. Those are both Z and T. They mean the same thing. But you got to show those angles are congruent. So number one, that's what you should have. Number two, what we'll do in number two, I'm going to kind of slide over here if I can. If I get this thing to slide over for me. And we are going to work out through a graph. If I could get this to move. It doesn't want to move. Okay, I'll live. I'm going to kind of do it up top here, if that's okay. But I'm going to take number two. I'm going to move it up here so I have some space. And we are going to do a quick graph. And I'm going to sketch these two triangles. And it's saying prove the triangles are with the given vertices are congruent. And if you remember back in 4.1, we were able to prove the triangles congruent through our translations and our transformations, our translations or rotations and our reflections. So that's what I'm going to do here. I'm going to show through our transformations that I can get this triangle to map onto this second triangle. So I'm going to take a minute here. I'm going to draw this figure out. I'm going to go out 7 spaces in each direction. Actually, I'm going to pause this and do that, and then you can do it yourself if you didn't do it last time in your reviewing, and then we can kind of go from there. Alright, so we got the pictures drawn. Now the first thing you should notice and what we're looking for is try to figure out a way to get this figure to be at least pointing in the same direction as this one. So I'm going to move this 90 degrees clockwise. And if you're going 90 degrees clockwise, so I'll go 90 degrees in that direction, then you need to make sure you know the rule. So you have X, Y, and then when you flip them, it becomes Y, negative X. Remember, if you're going 90 degrees counterclockwise, it becomes negative YX, but this is Y, negative X. This could be an important study tip for you to make sure you know your transformations. Once we do that, then we'll see what we need to do, if we need to move it up, down, left, or right, okay? But we at least know it's going to be facing the same direction, so then at that point I just need to slide it. So I'm going to come down here and we're going to do this one step at a time. This is part of our proof. This is really all we're doing, is showing that I can map these points onto one another. So I'm going to start with A, which is at 3, 1. I have B, which is at 2, negative 1. And C, which is at 7, negative 1. And I'm going to do a 90 degree clockwise rotation. It's going to look really tiny here. So that's a little arrow. It's like my little circular arrow. It's hard to see what's up here. Okay. and I'm going to do my y negative x. So I'm going to flip them, make my x opposite. So this will be 1, negative 3. Then I'm going to flip this, make that a negative 1, and then 2 becomes a negative 2. And then I have my negative 1, and then 7 becomes negative 7. And now I'm going to do one more transformation. In this case, it'll be a translation. I know they're facing the same direction now, so it's just about figuring out how I need to slide this figure to get it to map onto the original image. So I'm trying to get to P, starting at A. I'm at 1, negative 3 right now, so 1 has to become a negative 3. So I'm going to go, in this case, I'm going to go left 4, and then I'm going to go from negative 3 to negative 2, so I'm going to go up 1. And again, these are the two sets of transformations that I should use in my proof. As long as you're showing that work and stating it, you're proving it. So now let's see if it works. You got to show that it works. So this should be P. And that should be negative 3, negative 2. Just double check it. That makes sure that you know that you did the right transformation, didn't like not add something right or whatnot. So I'm going left 4. 1 minus 4 is negative 3. Yep, going up 1. Negative 3 plus 1 is negative 2. So that does match. Now let's try this on our other points and see if it works or not. Because it's saying prove that they're congruent, they better work. They're kind of telling you that it's going to be congruent. So negative 1 going left 4, that should put me at negative 5, which that's where Q is, so that's good. And negative 2, I'm going up 1, should put me at negative 1 where Q is, so that's a good thing. Negative 1, I'm going to go left 4, which puts me at negative 5, which again is a good thing. And then negative 7, I'm going to go up 1, puts me at negative 6, which matches R. Therefore, I've done my proof. Again, it takes your statements and your work. You can now state that triangle ABC is congruent to triangle PQR. And there's number 2. Alright, so that's 1 and 2. Let's move on down here, down the line. And number 3, classify the given triangles by their angle measures and side lengths. So I'm going to look at triangle ABC. So I'm going to go by side lengths first, and then I'll do angles. And again, what we're trying to do with the side lengths, figure out is it scalene, equilateral, or isosceles. Well, this has 2 congruent sides on it, so this would be isosceles. And in terms of angles, we're looking to see, does this have acute angles, or does it have an obtuse angle, which make it an obtuse triangle, or is it a right triangle? Well, in this case, you can see that this angle is obtuse. I mean, you don't really have to find it, you can tell it's obtuse, so this would be an obtuse triangle. Okay, so that's triangle ABC. Now you can try and go over triangle ACD. I can see the right angle here, that's going to help me with that one, but I'm dealing with the sides. You got your sides, you got your angles. Now this one is going to be isosceles as well, because you see how it has two congruent sides. So this is isosceles. And this one has a right angle, which means it's a right triangle. So those are your names for number 3. Alright, next up, number 4. It says one of the acute angles in a right triangle is a measure of 1. Measure of 1 1/4 times. So, okay, I'll get that. The measure of the other acute angle. So what is the measure of the larger acute angle? Now here's what you need to understand when you're dealing with a right triangle. These 2 angles have a sum equal to 90 degrees. So this one, they're telling you that this one of these angles is x, and then the other angle is 1 1/4 x. Now I don't like dealing with this, so I'm going to call this 4 times 1 is 4 plus 1, that's going to be 5/4 x. So that's what this guy equals. So I'm going to highlight that, So these are my angles. Now again, the key on this is that these have a sum of 90 degrees. So I'm going to use my small pen here because it's a really tight space. But I'm going to go x plus 5/4 x equals 90 degrees. So that's going to end up being, I'm going to write this now as 4/4 x because that'll give me a common denominator. 4 over 4 is 1x. So I now have 9/4 x equals 90. Now in order to solve this, I'm just going to multiply by 4/9. The 4's cancel, the 9's cancel. Come over here and multiply by 4/9. And here the 90 and the 9 cancel, that's 10 and 1. Therefore, I can state that x equals 10 times 4 or 40 degrees. Now, that was not the answer to the problem because they wanted the larger angle, which was 5/4 x. So I'm going to go 5/4 times 40, and let's see what we get here. 40 goes into 4, that's going to be 10. So 5 times 10 is 50 degrees. Now the other way you could solve this, once you had 40, again the concept is that these two angles add up to 90 degrees. So if one is 40, then 40 plus 50 is 90. You can do it that way. Alright, but number 4, you should get 50 degrees. Again, a couple concepts there you need to understand before you actually solve this problem. Alright, so that's number 4. Moving on here, let's go to number 5. An isosceles triangle has a perimeter of 34 centimeters. The congruent sides measure 4x minus 1 centimeters. And the length of the third side is x. So what's x? Okay, so I'm going to draw this figure so we can see it. Now, remember, isosceles triangles, two congruent sides. The congruent sides are 4x minus 1. So 4x minus 1, 4x minus 1. Third side is x. Okay, and they gave me the perimeter, so I'm going to set this equation up. I'm going to combine these two guys right here. So that's going to be 8x, and then -1 plus -1 is -2 plus x equals 34. And I'm just going to solve this equation. I'm going to have to work sideways here. I don't like doing that, but I don't have a lot of space. So it's going to be 9x minus 2 equals 34. So here I'm going to add 2 to both sides. So 9x equals 36. And then finally divide both sides by 9. And x equals 4. And they just wanted 4. There you go. Just about getting that equation set up, right? Alright, number 6 says the base. We have the base of a building. It's bordered by 3 streets. So I'm going to draw this building. Say we got this building in here. It's bordered by 3 different streets. I don't know if that's a scale or not, but who cares? We got Ronald, Reagan, and Egan. So I'll call that Ronald, Reagan, and Egan. It's a weird name. Okay. Now, from here, we have some information they're giving us about the side and the relationship between them. The Ronald side is 1 foot shorter than twice the Egan side. So the Ronald side, which is right, follow my, I'm on circling Ron right here. Okay, that is 1 foot shorter than twice Egan. So we're going to go twice Egan minus 1. So that's twice Egan minus 1. Egan Street, and there's a little typo in here, but Egan Street, I'll say it twice. You know, 1 for the end of the first statement and say it again for the start of the second statement. Egan Street is 8 feet shorter than half the Reagan side. So it's 8 feet shorter than 1/2 the Reagan side minus 8. 8 feet shorter than half of R. Then they tell you the Reagan side, which is 190. Well, that's nice. So I got 190. So we need to find the unknown side lengths and classify the triangle by its side lengths. So I would obviously start here. I got 1/2 r minus 8. So I can find the eigenside. I'm just going to plug in 190 for r. I'm going to go 1/2 times 190 minus 8. So that's going to give me half of 190. That's going to be, let's see, 95 minus 8, and I got my side length. Eigen is going to be, let's see, 90, 87. And that's 87 feet. Alright, now again, understand you already have, obviously, the Reagan side is 190. So that's kind of already given to you. So I just need to find the Ronald side. Call him Ron, save some space here. I know Eigen now is 87, so I'm going to go 2 times 87 minus 1. So that's going to equal, let's see, I know 80 times 2 is 160 plus 14 is 174 minus 1. And that's going to be 173 feet. So I got my lengths for all three sides, and they're not equal. So this would be a scalene triangle. So again, that's going to be number 6. Alright, moving on here. Try to go quickly as I can. I'll do orange. Go orange this time. Okay. Two sides of an equilateral triangle. Equal. So it's equilateral. All the sides are the same length. Okay. They measure, the two sides measure y plus 10 and y squared minus 2 units. Get rid of the e there. The perimeter is 21. What's the value of y? Well, it's equilateral, so this perimeter doesn't really matter. We just know these sides are all equal. So I would just then go y squared minus 2 equals y plus 10. And this is a quadratic, so remember how we solved these. We're going to set it equal to 0 and factor. So I'm going to go y squared. I'm moving the y over, so it's going to be minus y. Move the 10 over, and I'm going to have negative 2 minus 10. I'm going to have minus 12. And now we factor. And again, here you're going to ask yourself, what gives me y squared? Well, y and y does. And what multiplies to give me 12 but adds and subtracts to give me negative 1? Well, that's going to be 4 and 3. And if you want a negative 1, you have to have a minus 4 plus 3. Negative 4 plus 3 is negative 1. So these are your factors. Now set each factor. Oops, I did that wrong. Set each factor equal to 0. So I have y minus 4 equals 0, y plus 3 equals 0. So I get y equals 4 and y equals negative 3 for my values of y. Again, when you look for your values of y, again, understand your sides. You have a negative for y. That doesn't mean that it won't work in your sides, because once you've solved them out, they're all going to be positive. Negative 3 plus 10 is 7. And then 9 minus 2, because negative 3 squared is 9, minus 2 is 7. So it still works. Okay, so that kind of tells you these sides are all 7. You could have done it that way as well, I guess, with the perimeter. You could have said, well, 21 divided by 3 is 7. That probably would have been easier, actually. I could have gone y plus 10 equals 7, because the perimeter is 21. Sorry, I see it now. But it kind of, make sure you're doing it right. If you go y minus 10, you get negative 3. If you came over here, you get another answer. You get 4. You can get 4 on it as well. But depending on which one you plugged in. So anyway, 4 or negative 3 are your answers. Okay? Moving on, number 8. Okay. Number 8, find the measure of SRQ. So SRQ. So it looks like this angle right here. Given that angle P is congruent to angle U, angle Q is congruent to angle T, and the measure of angle RST is 37.5 degrees. Okay, so we need to find again the measure of angle SRQ. Now, in order to do that, I need to obviously try to do some triangle congruence here to try to show that these triangles may be congruent, and then I can find it. I do know that they, if I'm looking at these two triangles, they do or will potentially overlap. So if you want to make a really good guess, you can probably make the guess that angle P, I'm looking for what? SRQ. Sorry, well, it's the same thing. I was thinking PRQ. But SRQ would hopefully be 37.5 degrees. But with what we're given, we can't actually prove that because angle isn't a congruence theorem. So we are actually missing something for this problem. I'm going to put it in there so we have it. I'm going to put this point in here, x. And the other given information we're going to need is the following. I'm going to say x is the midpoint of ST, segment ST, and segment QR. And then finally I want to say that QR is congruent to ST. So I'll throw those in there. And what that's doing is that's telling us that these segments are all congruent. And then if we had that, if you look at ST and QR, I have angle, angle, side. And then starting at U here, angle, angle, and then ST, side. So I know these are congruent triangles. I also know that, again, this is an isosceles triangle, and I would then be able to say that's 37.5 degrees. But again, the way the question was worded, it wasn't giving you enough information. But we can still maybe even assumed it just by looking at it in a way, which, because it wasn't saying prove. That's the only way you'd be able to get by trying to do that. But again, we want to be able to prove it. So it's 37.5 degrees because we have an isosceles triangle. Alright, number 9. I'm going to find each angle measure. Now this one is dealing with a problem that is giving you two congruent angles. So I'm going to solve this. I need to use the exterior angle theorem. Exterior angle theorem states that the sum of the two non-adjacent interior angles equals the exterior angle. So this would be 2 times 6x minus 5. That is the same as this 6x minus 5 plus 6x minus 5. I'm just multiplying by 2 instead. And by the way, this is a equals 11x plus 1. So that would then give me 12x minus 10 equals 11x plus 1. Move the 11x over, you get 1x. Add 10 to both sides, you get 11. So I know that x equals 11. Then with the measure of angle C, which is this guy right here. So the measure of angle C equals 6 times 11 minus 5, which is 66 minus 5, so 61 degrees. So that's A. I'll keep going though. For B, we have we have two angles that are different now, so I'm going to do the same thing. 5x plus 2 plus 8x plus 4 equals my exterior angle, 15x minus 18. So here we add these two up, we get 13x. 2 plus 4 is 6 equals 15x minus 18. I'm going to move the 13x to the other side by subtracting it, so that's 2x. I'm going to add 18 to both sides, so that's going to be 24. Therefore, if you divide by 2, you get x equals 12. Now this wants x, y, z. So x, y, z. So that is this exterior angle, because it's y at y, but it's x, y. That's your vertex, z. So it's this guy right here. So I'm going to go 15 times 12 minus 18. Well, let's see, 15 times 10 is 150, plus 30 is 180, minus 18. So 70, 60, 162. And notice I'm not using a calculator. You don't need one for this test, obviously. All right, next up, measure of angle x. Now this one is not using the exterior angle theorem. It's basically saying we have two congruent angles, so I'm going to call them y and y. Actually, hey, let's just call them x and x. Makes sense, right? It's already x. Oops, I didn't mean to get rid of that last one. I just got rid of my circle. We're good. Okay, so I'm going to call this x and x. I said x anyway, so it just makes sense. It'll already be called x. We'll be good. But the equation here would be 2x plus 94 equals 180. So I'm going to subtract 94 from both sides. So I get 2x equals, I know if I subtract 80, that gives me 100, minus 14 more, so 90, 86. And then divide by 2, and I already have it called x, so I'll be good. So x equals, or I'll even say the measure of angle x, because x is x, right? That's going to be 43 degrees. Okay, moving on. Keep it going. So here I have no idea what that means. So this one we're going to find the measure, let's get rid of the 7, I guess. Find the measure of angle z. So here again, isosceles triangle, so I know the base angles are congruent. So that's where you would start. So I know these two angles add up to 70 degrees. So in order to find the measure of angle z, I'm just going to go 180 minus 70. So the measure of angle z is going to be 110 degrees. So we are flying through that. Okay, got some more here, very similar, just we're not finding the measure of angle x, so when we get to number 10, again, we're trying to, in this case, find I'm using the exterior angle theorem, but I need to find this angle before I actually solve this problem. Well, in order to do that, I have to do a little bit of work. Actually, no, I don't need to do that, I'm sorry. I can do this a lot faster than what I was thinking. I know that's 5x minus 40. This is all you really need to know. Okay? So that's this angle right there, right? So you got these two angles that are congruent because it's an isosceles triangle, so I don't need this angle at all, don't worry about it. But I know these two guys right here next to each other, those add up to 180. It's a linear pair. We know that a linear pair is supplementary, which means they add up to 180. So your equation would be 5x plus 5x minus 40. And I don't know if you notice, all my 4s, I don't know what's going on with this thing, but it always likes to connect those. That is a 40. I know it looks exactly like a 90, but it is a 40, okay? And that's going to equal 180. So this would be then 10x minus 40, okay, equals 180. So as I'm solving, I'm going to add 40 to both sides, so it's going to give me 10x equals 220, and then divide by 10. X is 22. That's number 10. Keep going. Number 11, find the length of the base. So I need this length. So I'm going to start again with my congruent sides. Let's find x. And again, I know x, I'm going to just use these two sides because I know they're equal, but if I can find x, I can plug it into my base. So here we're going to go 3x minus 4 equals, and that is a negative 3x, hopefully you caught that, plus 38. So if I add 3x to both sides, it gives me 6x. Add 4 to both sides, that's 42. And then divide both sides by 6, and x is 7. Again, they want the length of the base, so make sure you finish the problem. This is going to then be 4 times 7 plus 2. So that's going to be 28 plus 2 is 30. And they didn't really give me any units. You can call it U if you want, or units. or just 30. They didn't really say. So 30 units. All right, number 12. Number 12, again, different colors. I'm running out of colors here. There we go. I'm getting to like green, and then I have like black and gray. I'm going to have to go back. But here we're going to write an equation for the line parallel to the line shown that passes through the point 4, 8. This is going to be that point slope form that I'm going to be working with. So this is kind of an older concept, but it's something we should know. But I need a point and a slope. So I did my rise and run here, but I also got my point. So my point, before I do it, I should probably write point slope out to remind you what it is. And then I'll do all this stuff. So point slope form, the one I like, is y equals m x minus h plus k. My point, which is hk, is equal to 4, 8. They gave it to me. The slope, in this case, I could do my rise and my run. Looks like I'm going from 4 to 3. I'm going to go down 1, so negative 1. And I'm going from negative 1 to 1, so that's right 2. So my slope is negative 1 half. Down 1, right 2, rise over run. And then plug into your point slope form, you get your equation. It's y equals negative 1 half. I'm going to go x minus 4 plus 8. If they needed it in slope-intercept form, you can always just distribute the 1/2 and solve. But again, it just depends on what form they need it in. If I did do that though, if I distributed, this would be y equals negative 1/2 x plus 2. Half of 4 is 2, and negatives cancel, plus 8, and you would get y equals negative 1/2 x plus 10 if you went in slope-intercept form. So either one of those is fine. Alright, number 13. I'll do a gray just for fun. Okay, so let's do it. Okay, this one, find the missing coordinates. So this one, what you want to look at is this point. Okay, if we find the missing coordinates, understand I'm going right in. This distance right here is in. So if that's in, and I also know this must be h. Now, when I'm looking at this point, I know that's 0. That's a given because I haven't gone up or down. But we do need to figure out what the x value is. So the key to this is understanding this is n plus p, and that gets you all the way over here. Well, I know that's n, therefore I know this piece is p. That's just the side length. So if I kind of copy that side length over here, because again, n plus p gets me here, but if that's n, then this length is p. So that means this opposite side right here is also p, which makes that my x value. So this would be p0 for number 13. Alright, moving on. We got one more page to go. We're getting there. Alright, we're almost done. So 14. I have to pop back up here and see if I can find some colors. So I got a pink I can use. Haven't used that yet. Okay. Maybe I have, I don't know. But we'll see. Okay, number 14 says apply the transformation M to the polygon with the given vertices. Identify and describe that transformation. So this looks like we got a what's called a translation. And then we're going to do it. So here we got n prime. I'm going to go left 1, up 1. So left 1 is 0. Negative 2 plus 1 is negative 1. So there's n prime. Then we got L prime. I'm going to go minus 1. So 0 minus 1 is negative 1. 4 plus 1 is 5. And then I have P prime. And again, P is 2. So 2 minus 1 is 1. And 4 plus 1 is 5. There we go. Got our translation. Translation was left 1, up 1. Next up, again, I'll keep changing some, try to get some different colors in here. Ooh, that's an ugly one. I don't like that one. Let's go with, I've already used most of these. Alright, I'll do my dark ugly yellow, my puke yellow. Okay. Here it looks like we're doing a 180 degree rotation, so you have to know that. 180 degree rotation. and we just do it. So we go w prime is -5, -2. X prime is -2, -2. And y prime is -5, -5. Half the battle here is knowing your transformations. If you know them, you'll be fine. Otherwise, you're going to probably have a hard time, won't you? So make sure you're studying and know those transformations. Alright, number 15, we want to solve this system. Now this will be on your test. This is just some practice of systems of equations, so make sure you're kind of on the ball here. You know the 3 types of equations. Here's the 3 types of equations that you can have. I'm going to give you a quick heads up. One type of equation you can have is a quantity equation. So they're saying that you have, you're doing like a gas problem, and you said pump A got 200 gallons, or pump A got X gallons, pump B got Y gallons. Combined, they got 200 gallons. Your quantity equation is always going to be X plus Y equals a number. Always. This would be X plus Y equals 200 in the scenario I described to you. That's one type of equation you can have. It's a word problem. I'm giving you a hint. You might have a word problem and a standard one that's not a word problem. So the other type is going to be a relationship. And a relationship is always going to be Y or X equals some stuff. They may say Y is twice as much as X plus 2. So that'd be like 2x plus 2. Okay, and then give you a relationship. And the third type is a dual rate. A dual rate is basically your standard form equation, ax plus by equals c. An example of that would be the same gas problem. They say regular or gas pump or gas X was $2 a gallon, so you have 2x. Gas Y was $3 a gallon, and they made $400 that day, and there'd be your equation. So I want to make sure you understand how to set up these equations as well as solve them. Now I'm going to have to erase all this, so because I got to do this problem out and it's going to get in my way, but I want to make sure you have that. Okay, so to solve this system, we're going to looks like these are stacked, so, and I don't have anything solved. I'm going to use the elimination method so you can see how this works. So I'm going to take the second equation, I'm going to eliminate the x. I'm going to do that by multiplying by 3. So I want to call this again equation 1. I want to call this equation 2. So equation 1 is going to be exactly the same as it was. Negative 6x plus 2y equals 14. Equation 2 is going to change, however. It's going to be 6x plus 3y equals negative 9. I'm going to add these equations. These are going to cancel. I'm going to get 5y. 14 minus 9, so that's going to give you 5. So it looks like we get y equals 1. Now if y is 1, now you can find x, because 2x plus 1 equals negative 3. So I'm going to go 2x equals negative 4, so x is negative 2. And you can put your answers together if you'd like. They are basically an intersection point. So it'd be negative 2, comma 1, and you would be golden. Alright, number 16, they're asking you to determine whether the lines are parallel, perpendicular, or neither. Now this is all dealing with slope. So parallel lines are going to have the same slope. Perpendicular lines are going to have opposite reciprocal slopes. And if they don't have any of those situations happen, then it's going to be neither. So when we do a problem like this, you need to be able to calculate the slopes. Now, this problem doesn't really do a great job of giving you a point, so I'm going to kind of pretend like these points are they're giving me points. I'm going to assume, and this is not true, but let's just say this point is at 1, 0. Say it's not drawn to scale. And let's say I had another point down here. Looks like I'm at like maybe 2, negative 1. So that's going to be the points for the red line. The other one, I'll do a different color. I'm going to say, let's say it goes through 3, 0. And say it goes through, say this point right here is negative 2, negative 3. So what I would be doing is finding my two slopes. So let's find those slopes. I'll color code it so you know which ones I'm doing. So I'm going to find the slope here, and you can do rise over run. So I do rise over run. Looks like I'm rising 3. And I'm going to run from -2 to 3, so that's 5. So that's rise over run. Do the same thing with my second line. Find that slope and see what relationship I have. Here it looks like I'm going down 1, right 1. So down 1, right 1. So this would be a neither, because they are not opposite reciprocals. Again, basically I'd be asking myself, if these were perpendicular, if I got 3/5, I better have -5/3. And I don't, right? So this is neither. That'd be your perpendicular slope. Obviously they're parallel, they'd be the same number, and they're not. Okay, so that's 16 as best I can do based on all the points I gave you. And if you looked at it, you can probably see they're not a right angle. That's why I had to again say they're not drawn to scale. They're just giving you the points, and how do you deal with it? Okay. Alright, so for these next ones, obviously we need to write a 2-column proof, so we're going to set up our chart. So I'll do that real quick and then I'll hit play. And again, all I'm going to do, I'm going to fill out the chart and write the given statements, okay? Alright, so here we go. Anytime you have a proof, draw the dang picture and label the congruent parts, please. Okay, so I have too many people, you just try to not draw a figure, and you're like, well, and I get the questions of, what congruent statement do I use? Well, if you looked at the figure and labeled it, you'd be able to tell, but you're trying to do it all in your head. Don't do that. Write the picture, label it as we go along. BC is congruent to EC. I'm going to label that. AC is congruent to DC. And this also, notice what this will help you do. I can tell that this can be, I can prove this similar, or not similar, congruent now by side angle side if I labeled those congruent. It's easy to see that though, when you have the picture in front of you, but if you're trying to do it all in your head, that's not going to happen. So draw the picture. It is not that hard to do, seriously. So I'm going to label these angles congruent. If you don't see why, well, you should realize these are vertical angles. It's one of our reasons we've been using quite a bit. You can't say angle C, by the way, because there's technically 4 angle C's, so I wouldn't know which one you're talking about. You have to use the 3-point method. So angle BCA is congruent to angle ECD by the vertical angle theorem. Now again, I'm trying to prove segments congruent, and that makes me think CPCTC. But I can't use corresponding parts if congruent triangles are congruent, CPCTC, unless I prove that the triangles are congruent. So your first thing that you need to do is state that triangle BCA is congruent to triangle ECD by side angle side. So if you understand, the order matters when you do your congruent statement. So since I already thought about it up here, I made sure I did it correctly. I did B, you see how that's that 1 tick mark, BCA. So I did the 1 tick mark side first, I went ECD, and the order has to match, which it does. So you can't just do it in any order that you want, or else I will mark that wrong. So step 4, now that we've proven the triangle is congruent, we can now use CPCTC. BA is congruent to ED because they're corresponding parts of congruent triangles. So write your statement. BA is congruent to ED by CPCTC. There you go. There's your proof. This would be a proof that I wouldn't mind you filling out on your own for the most part, because it's not anything crazy. Alright, number 18, I'm going to do the same thing. I'm going to draw my chart. So pause the video, draw your chart as well, and let's see how we're doing. Alright, so here we go. This is a very similar proof to the one we just did, in the sense that I need to do vertical angles on this one. I got more vertical angles. Notice here I'd get angle, side angle if I do that. So I'm just going to go step 2. I did different colors just because they're so close together. But I'm going to say angle. I'll go IJH is congruent to angle KJL. Make sure you're going in the right order. And that's the vertical angle theorem. This is only 3 steps. I have angle, side angle already, so step 3, triangle now, IJH. is congruent to triangle KJL. And again, that's just good old angle, side angle, vertical angle twice. Okay, hopefully you can spot vertical angles and state the congruent when they pop up, because it's pretty simple. Just write it up correctly and you'll be okay. All right, number 19. You know the drill. Let's pause the video and write your chart. Alright guys, and this is another pretty quick proof, but the best advice I can give at this point though is to take these triangles and pull them out so you can see what you're given. It's hard to label the congruent parts in here because you're like, okay, where does this, where does this congruent tick mark go with, and what does it go with, and all that. So I just drew the triangles out here separately. Now with that, you got your given statements. Now you got to figure out, what can I now label? Now this is not a vertical angle situation, but look, they both of these triangles, see how they overlap right here at this angle? That's the same angle, guys. So I can label that angle congruent to itself. Angle L is congruent to angle L. This is your reflexive property. It works with sides and with angles. It's a reflexive property of congruence. So this allows you to, in step 3, say that the triangles are congruent. Triangle L, say that right, L, mess that all up, okay, triangle JLM is congruent to triangle NLK, and that by side, angle, side, side, angle, side. So there's some pretty quick, simple proofs. Hopefully you're doing good with those and you can do those on your own. Then we're going to go down to number 20, our last one. So this one is asking you, giving you a figure. We're going to prove this more algebraically. B is a right angle, D is the midpoint of AC. So this one, when we're doing the coordinate proofs, remember what I do on these? If they're giving you a midpoint, we need to find the midpoint. I'm going to use this for my proof. So first thing we're going to have to do, say since D is the midpoint of AC, I can do the following. D equals, it's going to be 0 plus 2n over 2, midpoint formula, guys, x1 plus x2 over 2. Add your x values, divide by 2. Add your y values, divide by 2 as well. I'm going to go 2j plus 0 over 2. That equals 2n over 2 is n. 2j over 2 is j. So I have nj. Now that I have that, I can now find my area. So I can say since the area of a triangle is 1/2 base times height, I can say that the area of triangle, and I'm trying to say triangle DBC and ABC, so I'll go DBC equals 1/2. I'm doing DBC, so that's this triangle right down here, the bottom one. A couple things here. We need our height. It looks like I'm going from 0 to j, so that's j. The height goes from 0 to 2n, so the base is 2n. So it's going to be 1/2 base, which is 2n, times height, which is j. So that's going to cancel, and I get nj for my area. And do this one more time with my other triangle. I did DBC, now let's do triangle ABC, the big one. The big one, I have the same base, but my height is now different. It's now 2j. So this area of triangle ABC equals 1/2 base, which is 2n, times height, which is 2j. These 2's cancel. You have n times 2j, which is 2nj. So these are your two areas. Now the area of DBC is supposed to be 1/2 of triangle ABC. So I can then say at this point, so 2nj equals 1, or oops, I said that wrong. Sorry guys, I'm setting up my statement right now. that. Now I have to go back to show you. Should I keep it so I can keep everything in one spot? Okay, I can fit it in there now. All right, so I'm trying to say the area of DBC is half the area of ABC. So NJ is basically 1/2 times 2NJ. You can make that statement. And the reason why you can make that statement, I'll scroll down again, is this would be NJ equals 1/2 times 2 is NJ. So therefore, since I've kind of shown that, the area of triangle DBC is 1/2 the area of triangle ABC. So it's about showing your work on these and showing them algebraically, but if it's a proof, you got to show your work. That's really the key on this. You have to show all the work that got you there. So basically I'm looking, I'm looking for that statement obviously, but this is what's important. You got to show that before you can say that. And you have to define that. You need to find your midpoint. So you have D, so you know what the height is. So all these things kind of tie in together, okay? So anyway, what I'll do here is the end of the video. I'm going to slowly kind of scroll through these answers. So if you're checking now, this is what the first thing you should be doing. You can check your answers. So you can pause the video at each part. Okay, so these are your answers. I'll shut up for a minute. Well, let me see if I can. Okay, so it looks like I'm going to scroll down. Yeah, all right. So just take a minute and check your answers. All right, I'm going to scroll down. All right, I'm going to scroll down a little bit more. And I'm going to scroll down to the final page. I'm going to have to do it in 2 parts. And finally, to let you see number 20 and 17 and 18. All right, so at this point, again, make sure you check those answers. If there's any ones that you want to review, then make sure you go back to the video where I went over that question and catch that review. And as always, guys, good luck. I'll see you guys when we come back from break.